Hello all, welcome to Now You Know channel. In this tutorial, we are going to implement stack data structure using arrays. The another name of stack data structure is LIFO data structure. LIFO stands for last in, first out, meaning the element that goes last will be the first one to come out. So here I have taken example of stack size 5. I am trying to push some of the elements to the stack. So push 1, push 2. From push 2 onwards, if you can observe, the element that goes to the stack will be the top most element of the stack. So similarly 3, 4, 5. So since after pushing the element, fifth element, which is 5, the stack is full. So when I'm trying to add the sixth element, I mean pushing the sixth element to the stack, so we should get stack overflow. So after push operations, so we are trying to pop the elements from the stack. So the latest element in the stack is 5. So 66, for pushing 6, we got the stack overflow. So we are unable to push. So because our stack size doesn't accommodate the sixth element. So from pop, we got the latest elements 5 and similarly 4, 3, 2, 1. So after popping the last element from the stack, which is 1 in this case, so again trying to pop the elements from the empty stack, we should get stack underflow. So let's see how to implement the same in Java. So here I have already created a stack class. So first thing first, we will be needing a constructor with size as a parameter and size. I will be needing a instance variable to set this size. This dot size equal to size. So since we are going to implement stack using arrays, we will be needing an array, a generic array, which I'm going to call stack. Let's initialize that one. So this dot stack equal to, since we cannot create a generic array, so we need to wrap it around a generic array and create a new object array with the size that is coming from the constructor. So I'm going to introduce one more variable, which I'm going to call index. So this particular variable, this particular index variable plays a central role to check the bounds of the stack. So we'll get into that. So when we are implementing the push and pop methods. So for now, I am going to initialize index equal to size minus 1. So the index will be pointing to last index position of a stack, this stack. So that's pretty much of constructor. So let's try to implement methods like the core methods of stack, which is push in this case, which takes a value. Okay, the simple expression to push the elements to the stack is this dot stack. So remember, we are initializing, the index is pointing to when stack is instantiated, the index is pointing to last index position of the stack array. Here what I'm going to do is this dot index minus minus equal to value. So let's take the same example. So when let's take the same example. When stack size is 5, when push 5, I'm adding the 5 elements to the stack is completed, and trying to, we need to check this, basically we need to check this case, whether stack is full or not. So for that, I'm going to introduce a method, which I'm going to call is full, public boolean is full. So here I'm going to return a simple expression to check this dot index is less than 0. So remember, when stack size is 5 for an example, and we have already pushed the 5 elements, so that time the index will be pointing to minus 1. So this is the reason we need to check this condition is full, and I'm going to print system.out.println stack overflow dot 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 and return from this point. We don't need to proceed for adding the element to the stack, because at this point the index will be -1. We will get, if we don't return from this point, we will get array index out of bound exception for the stack generic array. Yeah, so that's pretty much about push logic. So let's see how to implement a pop logic. Public t pop. So pop doesn't take any elements, but instead it will return the latest element from the stack. The simple expression to return the latest element from the stack is this dot stack, this dot index. So what I'm going to do is I'm just pre-incrementing the index, because when we push methods to the when we push elements to the stack, the index will be pointing to one less than the current index. So that is the reason I'm pre-incrementing and returning the value present at that array position. So similarly, we need to check the same condition here. Then in case of stack is empty, we should check this condition. So for that, I'm going to introduce one more method, is empty. Public boolean is empty. I'm going to return a simple expression, this dot size -1 equal to this dot index. When index is pointing to the last index of the stack, which is in this case this one, so then we say the stack is empty, which means we have already written from that point and it is pointing to the last array index. So remember, we are post incrementing this. That is the reason I'm checking this equal to condition. So when the last element is popped from the stack, so it will be pointing to last index. So that is the reason we should check condition like this. So similarly, to check this condition, I'm going to add this is empty. I'm going to print stack underflow and returning null. Yeah, so that's the logic of push and pop, and is full and is empty. So let's test with adding some of the elements and popping the elements from the stack. So main stack of type integers, so I'm going to call stack new stack of size 5, and I'm going to add I'm going to push some elements to the stack dot push. So let's add 5 elements, 2 3 4 5. So at this point I'm going to check whether the stack is full or not. Is stack full? Stack dot is full. So I'm going to add 6th element here, 5. So let's change this to unique elements. So yeah, let me pop the elements from this point. Let me pop elements 3 4 5. I'm going to check at this point. I'm going to check whether stack is empty. Yeah. So again, trying to pop the elements from the empty stack. So the expectation here is we should get true or true in the console after execution of this particular statement, and here I should get a stack overflow in the console. So at this point we should get 5 4 3 2 1. So at this point we should get true again because the stack is empty. We have already popped all the elements from the stack, and here we should get stack underflow /n and a null element, null value in the console. So let's test this one. Yeah, so console, it has printed already e stack full. So here e stack full is true, we got true, and when trying to add the sixth element, and we are getting stack overflow. And similarly for pop we got 5 4 3 2 1, which is right. And I'm checking whether the stack is empty at this point. Yes, it is empty, and I'm trying to pop the elements on the empty stack. So we are getting the stack underflow, and then it is returning null. So that's the end of this video. I hope you enjoyed watching this video. So if you like if you want to see more videos like this, so please subscribe to our channel. Thanks for watching. Thanks for your time. Bye.